So we're going to start working with functions such as a function like f of x equals x squared divided by x cubed minus 8, or g of x equals x squared plus 1 divided by x cubed minus 7. Okay, these functions are rational functions. So what is a rational function? A rational function is a function that is made up of a polynomial and a polynomial and is defined by the division of those two polynomials. So the way we're going to represent rational functions is f of x is going to be p of x divided by q of x. P of x and Q of x are polynomial functions, and Q of x, of course, the denominator is not zero. We all know that division by zero is not possible in mathematics, so Q of x cannot be zero. So when we talk about domain of functions, we know that the domain of any function consists of all values of x, of the input for which the function is defined. Since we just know that division by zero is undefined, when we talk about the domain of rational functions, we are going to be excluding the values of the input that make the denominator of the function equals to zero. So what do I do to find the domain of a rational function? I'm going to have to set the denominator equals to zero. I have to solve, and I have to determine the domain by way of dissolving. In other words, what I'm going to do is I'm going to say that domain is all real numbers except the solutions found in the equation I solved. Let me give you, excuse me, let me give you an easy example to follow. So let's take the rational function defined as 1 over x. This function is a rational function because the denominator and the numerator are polynomials. Okay, so how do I find the domain of f? Well, the domain of f, but what I'm going to do is I'm going to follow these steps right here. I'm going to set the denominator equals to 0. The denominator is this, right? I'm going to solve. I really don't need to solve because x is equal to 0. And the domain is all real numbers except the solutions found. So the domain of f is all real numbers, right? Except x equals 0. Now, if you place this function in your calculator, you do y1 equals 1 over x, you will see that the graph that you obtain, and you can do a zoom 6 to graph this function, you're going to see that the graph of this function is going to be represented by this in the first quadrant and by this in the third quadrant of the plane. Okay? What this represents is a function that does not have an output for x equals 0. You see, for x equals 0, f is not defined. Okay? So again, the domain of f is all real numbers except x equals 0. Let's do another example. Let's take g of x equals 2 divided by x minus 2. Okay? So if I have this function and I want to find the domain, I take the denominator and I make it equals to 0. I solve. So the domain of g is all real numbers except x equals 2. Okay? So this is another example of how to find the domain. Again, the first thing that you do is you set the denominator equals to 0, right? The second thing you do is you solve. right? And the last thing that you do is you take that solution and you exclude it out of the set of real numbers. Okay, so let me do this. Okay, so this is example number 2. I'm going to take example number 3, and I'm going to take the function f of x equals 2x plus 12 divided by x minus 4. Okay, again, I don't need to worry about the numerator. I need to worry about the denominator. Okay, that's where my problem is. So the first thing I do is I set the denominator equals 0. The second thing I have to do is I solve. Yes, and now I have the value that needs to be excluded out of the set of real numbers for the domain. So the domain of this function I have here is all real numbers except x equals 4. Okay, let's do another example. And now we're going to take f of x. So things are going to get a little bit more complicated. I have 1 divided by x squared plus 7x plus 12. This is a more complicated problem because now I have a quadratic expression in the denominator, but I'm going to work in the same way. So let's see what I need to do. Again, I set the denominator equals to 0. Okay? And then I solve. Remember that when you have a quadratic equation and you need to solve a quadratic equation, the first thing that you need to think about is whether or not you can factor. So I look at my value of c, this is a trinomial, is 12, and I think I can factor this. So I think of two numbers that multiplied give me 12 and added give me 7. So those numbers are 4 and 3. Yes? So the solutions are x plus 4 is equal 0 or x plus 3 is equal 0. So we have two solutions. X is negative 4 and x is negative 3. Yes? This is either one of those two solutions will make the denominator equals to 0. So what is the domain of f? The domain of f could be all real numbers except the ones that were the solution for the equation I just saw. So x equals negative 4 and x equals negative 3. Okay, let's do one more example. And now we are going to take f of x equals x squared divided by 5. Okay, so what kind of equation is that? So let's make it the denominator, and let's say the denominator is equals to 0. Question, can 5 be equals to 0? Absolutely no. So what this means is that the domain of f, yes, is all real numbers. Okay, let me see, this example is example number 5. Okay, let's go now with example number 6. I have f of x is equal x squared minus 8x plus 12, and we're going to divide these by x to the third minus x. Okay, so again, I'm going to find the domain, take the denominator, x cubed minus x, set it equals to 0. Remember that you have to solve an equation. The first thing you need to think about is, can I factor this expression? So I'm going to look at the expression on the left, and yes, I can factor. Yes, and I keep thinking, am I finished factoring? I can still factor this expression because this is a binomial that is represented by the difference of two perfect squares. So it's x minus 1 times x plus 1. I hope you remember this. So how many solutions do I have? Well, I have three solutions. X equals 0, x minus 1 equals 0, that means x is equals 1. X plus 1 equals 0, that means x is equals to negative 1. So now the domain of G, rather the domain of F, is going to be all real numbers except the three numbers we found here. We found 0, 1, and negative 1. I'm going to list them from left to right, so except negative 1, x equals negative 1, x equals 1, and x equals 0. Okay? All right, so let's review what we just learned. We learned that rational functions are functions that are defined as the division of the quotient of two polynomials, where the polynomial in the denominator cannot be equal to 0. We also learned that the domain of rational function is determined by checking the denominator, looking at the denominator and finding the values that make the denominator equal to 0. So the steps to find the domain of rational functions are 1, 2, and 3. Set the denominator equals to 0, solve, and the domain now is all real numbers except the solution of that equation we just solved. So we did several examples. Some examples have linear functions in the denominator, or linear expressions in the denominator rather. So we have 2 and 3 have linear expressions. Number 4 has a quadratic expression. Number 5 has a constant, and number 6 has a polynomial in the denominator that has an exponent greater than 2. So it's a little trickier to factor the denominator in this case.